Good morning. We shall see about the strength of organic acids and bases in terms of pKa value. In the previous video, I have explained about what is Ka, what is pH, what is pKa. pH is nothing but the potential of hydrogen ions, and Ka is the acidity constant which quantifies the proton transfer in a reaction, and what is pKa is Ka negative logarithm of Ka, and that is that gives the equilibrium between a proton transfer reaction between the reactants and products. So now in this video we are going to see about the organic acids and bases. Now see this one. Next we will see what is the role of pKa value. It plays a very important role in understanding the basic reactions, that is acid base reactions in organic chemistry. Okay, see I have represented pKa is equal to minus logarithm to the base 10 Ka, and here we can see the representations, that is what represents strong acids and which one corresponds to weak acids. See the value, the below values are Ka values and the above values are pKa values. You can easily see 10 to the power 4 it is minus 4, 10 to the power minus 2, so 10 to the power 2 it is minus 2, 0 it's 0 and minus 2 it's 2. Okay, see why we are using pKa value instead of Ka value, because see in the case of acetic acid it is 1.8 into 10 to the power minus 5, that is the Ka value which shows the acidity constant. But see easily we can remember that its pKa value is 4.8. Simply have to find out the anti-logarithm. Okay. So it is very easy to remember the pKa value than remembering the Ka values. So usually organic acids and bases are represented by their pKa values. Okay. Now coming to see which compounds are called as organic acids and which compounds are called as organic bases. That will be clear when we discuss how the organic compounds react. Okay, see most of the organic acids are carboxylic acids. Now we will see the reaction in the later pages. Okay, the most organic acids are carboxylic acids, and that that compounds have a functional group COOH, and the ranging pKa values range from 3 to 5, which shows that they are strong acids. So in the previous video I have explained that when the Ka value is higher, the pKa value will be lesser. So with the pKa value 3 to 5 corresponds to moderately strong acids. And so you can see acetic acid the value is 4.76 and the formic acid the value is 3.75. And also alcohols are also considered to be weaker acids, and which have that alcohol groups, the functional group is OH, alcohol. Now see the values, pKa value is 15.5 for methanol, and ethanol it is 15.9, which shows that they are very weak acids. Okay, and now see how we can find out these are called as organic acids and these are called as organic bases. See, for this we'll see the terms with water. Okay, see the reaction with water. Water can behave both as an acid and as a base. The similar way carboxylic acid and alcohol can act. See the reaction when water is along with the compound which is lesser basic, it acts as an acid. Compound along with the water, when it is a more basic substance, it acts as a base. Okay, see this, an acid with in the presence of an ion, that is the OH minus ion, that is a strong base, it is converted into methoxide ion and water. So here what happens is this can act as an acid since it donates a proton, because the base is a base one which we have added is a strong one. In the second reaction you see this CH3OH plus H3O plus ion. Here this acts as an acid and this donates a H plus, and so what happens, alcohol turns into a base. So now simply by seeing the reactions we cannot say whether it is a strong acid or a weak acid. For that we have to remember the pKa values. See the acid also, when it is with a base it reacts as an acid. When it is with an acid it reacts as a base, it is corresponding to it. Okay, now we'll move to the next one. Next, another important point what you have to remember is a compound which with the proton, or it is a protonated compound, okay, that has gained a proton, that will be more that will act as a more strong acid. It will be a very strong acid. See, protonated methanol. See the value, pKa value, it is minus value. So minus means it's a very, very high, that is acidity is very high. Okay, pKa here, protonated ethanol, and then protonated acetic acid. See, these all have negative values, showing that they are all very strong acids. Now, coming to our bases. See, the base, we are considering this amine, NH2 group. A compound with NH2 group is a base, and we are saying that is methylamine. Methylamine, when it is reacts with a strong base, here it acts as an acid. When it reacts with a weak base, it acts as a base. Okay, see here it is ready to accept H+, and in the first case it is ready to donate H+. So amines are, again, see how we can say they are all bases. See their pKa values. See the pKa for methylamine is 40. See the value very, very high, and so it acts as a strong base. And it's a weak, very weak acid, that we can say it is a very strong base. Okay, ammonia, see the value, it is 36. So we can say these are all weak acids, or that is they are all bases. And there is one more question. Why we are talking about pKa value, not why we are talking about acidity constant, and that is a negative logarithm. Why we are not saying as a basicity constant? Because instead of using basicity constant, it is more easier to represent in the same term as acidity. So that we can easily remember. Okay, so see the strength in the base of Kb value is, it is not easier to talk, easier to remember. So strength of its conjugate acid is indicated by its pKa value, and the stronger the acid, the weaker is its conjugate base. For example, protonated methylamine, see the value, it is very less. So it acts as an acid. And here see protonated ethylamine, again the value is less, and so it can act as an acid. Okay. Now see how to remember the pKa values. See the pKa values, when they are, you can see here, they are protonated alcohol, the pKa value will be less than 0, that is minus values. And for acids, the pKa value is approximately from 3 to 5, and protonated amines will have the range approximately 10, and pKa value for alcohol, it is approximately 15. So very strong acids means pKa value will be less than 1. Moderately strong acids means pKa value will be between 1 to 5. And weak acids, usually alcohols. Okay, moderately strong acids, weak acids, alcohols 5 to 15, and extremely weak acids, the pKa value will be greater than 15. Okay, see here I have given another thing. For carboxylic acid, the value range, and the alcohol, aldehyde or ketone, alkynes, amines, alkenes, and alkanes. See, that is given in the order. So in organic chemistry, organic compounds, carboxylic acids are considered to be as strong acids. Next comes alcohols, and then aldehyde, ketone, and then come alkynes, because hydrogen can be easily removed as H+ in the case of alkynes. Amines, alkenes, alkanes then. Okay. And another one more point I have to stress is, here by seeing the values of pKa, we can say whether it acts as an acid or a base. See here, for example, I have taken acid HCl and water. Here pKa value of HCl is 7 and the base is 15.7. See what happens here, pKa value, that hydrogen acid, the value is high, so it acts as a strong acid, and here the water, the value is 15.7, so it acts as a base. So if the pKa value is higher, it will be an acid, and if it is low, it will be a base. Okay, see this pKa values of the reactants, see base 36, and here it is acid water 15.7. So what you can say here, water acts as an acid and ammonia acts as a base. Okay. And now there is another important point. What happens to the position of equilibrium when you are taking an acid and a base, and what you can understand from the pKa values? See what happens is, always the equilibrium is favored towards the weaker side. What is that is, only a stronger acid and a stronger base will readily react to give a weaker base and a weaker acid. Okay, so the the equilibrium will always be shifting towards the weaker side. Okay, see in the example, pKa value of acid, that is an acetic acid, it reacts with a base. So this one is a stronger acid, and stronger base will react to give a weaker base and a weaker acid. You can see the pKa values. It is 4.8 and here it is 9.4. And here see the another example, ethanol with methylamine. Here also the stronger base you are getting. So see the position of the equilibrium. Here it is shifting towards the right, and here it is shifting towards the left. So the total, what is the point we have to insist is the equilibrium always lies away from the strong acid and it is towards the weaker acid. Okay, so these are the things that we have seen today. Thank you.